Today we're going to talk about the DevOps with Kubernetes, and I have Daniel Selman with me. Hey, Daniel, want to introduce yourself?
Yeah, hey, my name's Daniel Selman. I work heavily with Kubernetes and DevOps, and so we're excited today to talk about Helm, a tool that really enhances DevOps integration on Azure.
All right, so what we're trying to do is spend more time in walkthroughs and demos rather than talking about it, but there's some structure to the conversation. So we'll talk about the Helm, we'll talk about the Helm charts a little bit. Then we will go and look into a sample application that we have that we wanted to deploy in Kubernetes. I think it's not necessarily important the nature of the application. It's just a canonical small application with a front end and the back end. But we'll actually go and look at a VSTS build pipeline because that pipeline is important. It will create containers. It will create necessary artifacts needed for the Helm to deploy in the later steps. So once we look into the VSTS build, we'll look into the release here. So the release would be the next thing. And there is a specific task for Helm to deploy on, using Helm to deploy on AKS. So we're going to look into that. Before we start, let me just show everyone the demo part of the environment that we have. We created an application. Everything is running on Azure Kubernetes Service, AKS. So if you're not familiar with it, I'll show you real quick. Super easy to create the team services, Visual Studio Team services. So as for the application goes, I think the easiest way is this is the application running in Kubernetes cluster hosted on Azure, but we will see how we get here. But the actual code is available on my Git. So there's a link below that you can download it from, and there's a Helm sample here. And basically the idea here is that a simple application, ASP.NET Core front end, and with the Node.js API backend. And there is quite a holistic blog post that me and Daniel wrote together. We're still working on it. If you wanted to really dig deeper into the specific code and all that, then you can download this. So what I did, I basically have it running here. So if I go back, I should have it open in Visual Studio Code. It's again a free software. You can download it. Works cross-platform. This is the ASP.NET Core. I think one important thing here is the Docker file, which, as you can see, that's super simple. 2.0 ASP.NET Core 2.0 application with port 80 exposed, and that's this application actually make a call to the backend API, which is basically written in Node, and the Node itself also pretty straightforward. So we expose few endpoints, and the application itself shows various historic events. So we have Renaissance, French Revolution, World War I, World War II. So more education side and works. I mean, if I click here, it will show me all the important events that happened over the years during French Revolution. You can actually set it up and running locally. I mean, if you have Docker, there's a Docker file, so you can do a basic run of testing with it. But what we really want to talk about is when you pick this application and take it, and then you wanted to have a proper a build and release pipeline, and using a tool like Helm, it will make your life easier to package this. Now, from the infrastructure side, I have created a cluster here. So this is let me zoom in a little bit here. I have my AKS cluster. It's super easy to create these things, so I'm not going to create it right now, but I will just show you real quick. If you want to create one, you will say Kubernetes, and it should come up. So we have Kubernetes service here, and this is basically you go ahead and create it, and you provide details here, and that's pretty much you can do it this way. Now, if you are
to chime in here. This also, working with AKS streamlines all the environment-ready configuration. No longer do you have to worry about configuring what your master nodes look like and what each of the configurations for the worker nodes need to be. Rather, it just works out of the box, which is the big advantage here. Similarly, just as simple as this GUI is, creating a Kubernetes cluster now is just a simple command line where you just pass it the name of the cluster that you want and the and the resource group for it, and then you have a Kubernetes cluster up in just a matter of minutes.
Yeah, I mean, that's pretty much, I think, covers some of the basic things here with the AKS cluster. Now, if you are using Azure CLI, then basically you can do AZ AKS command, and I think this is the one. Yeah, so you can see that you can actually use the create command. So if you wanted to use automation and tooling, then this is the way to go. Now, it takes 2 minutes to create it, so I already have a cluster ready for us, so I'm not going to go into further details here. And finally, we need to talk about the Visual Studio Team Services. So the Visual Studio Team Services, I have the build definition here. So the code base is the same that I showed you earlier, and we'll go through it a little more deeper detail later in the talk. So, and then we have the release definition here. So, and again, just to be concrete about things, you can use any other pipeline or the release management tool. I mean, there are like Jenkins, you can use Git, you can use even like a native Kubernetes brigade if you want to, and we're probably going to cover them in later talks, but I think VSTS is definitely a product that is resonate with the customer, so I want to make sure that cover that up front. So with that, Daniel, you want to talk about the Helm and just maybe introduce what Helm does?
Yeah, thank you, Razi. So Helm is essentially a package manager for Kubernetes. It works natively with Kubernetes, and you can just think of it as the apt-get. Instead of typing apt-get, you just type Helm instead. It also has a command line, command line tool that you need to install separate from kubectl in order to really get the benefits of the native Helm functionality. What it does is it really streamlines the way that you want to that you can install applications. For example, a big advantage of containers and Kubernetes and container orchestration in general is that it allows you to break down larger monolith applications into microservices. This means taking an application that was one single component and making it maybe dozens of components instead. Now, the headache that comes with that is that all of a sudden we have all these different parts that we need to be able to manage. And with Kubernetes, once you start fleshing out applications, even the application that we have, the 3-tier setup, front end, API, and back end, even that becomes many files that you have to define and keep up with. And so for people not extremely familiar with this, it can be a challenge. You need to be able to install different components of an application in a particular order. This is augmented by the fact that oftentimes you have configurations that are spread out in services or in secrets and config maps, which mean that there are dependencies in the order that you install certain resources. Helm really streamlines that. Now that we've kind of broken down larger applications into smaller microservices, it allows you to then package up all of the files, and it handles the installation of the application without having to worry about any dependencies. You just throw all the different YAML files associated with some application into a single Helm chart. So just as when we talk about things around Kubernetes, oftentimes everything's very nautical. As you can tell, Kubernetes is Greek for helmsman. Helm kind of makes sense for being a package manager. But when we talk about packages, we're talking about them in the context of a chart. So additionally, it's maintained by the Cloud Native Computing Foundation. Oftentimes, you'll see every really big open source tooling around Kubernetes is donated to them. This is no different. It's also maintained at helm.sh if you're curious in learning more about it and learning more about the syntax. Now, another advantage of this is that it allows you to parameterize YAML files for your Kubernetes deployments. So what does that mean? Well, oftentimes when working with YAML, you'll find that you need to make slight modifications when deploying to different environments. For example, if you have a QA cluster and a production cluster, then you'll want to make sure that the labels associated with the application are updated for the particular tier or cluster that it's in. Now, you can do this through your CI/CD pipeline, so installing environment variables within the pipeline that are injected during the build and release process. However, it's oftentimes better to minimize any dependencies on those external things. CI/CD pipelines, for example, can change. You might be working with VSTS one day and want to work with Brigade the next. And so Helm provides a kind of Kubernetes native way to inject those parameters at build and release time. So those are really being able to package up your applications, and then parameterizing YAML are the two big advantages of using Helm. Essentially, once you're really working with microservices in production, or just microservices across a large scale, this is going to be a tool that simplifies the build and release process for you.
Okay, so
Razi, do you have anything to add on that?
now, I think what we can do now is maybe we can quickly go to the website here. Let me go and go to the helm.sh. And one thing I will call out is that if you want to do install it, the instructions right here. So this is like really no-brainer, cross-platform. I mean, Helm relatively, and other tools too, are relatively new compared to some of the more mature like kubectl. So it's always evolving as other things in Kubernetes, so keep that in mind. I have it up and running, so we can go and take a look at the console over here. Let me zoom in a little bit. So I have a Helm install. So here you go. One thing that we can show, Daniel, is that we have the application cloned here. So I have that, and part of that code base is the Helm chart. Now let's clear it. So if you look at the Helm charts over here, the structure is like there's a chart which is essentially going to describe the structure, and then there are values. And I mean, the whole concept, as you described earlier, Daniel, is that rather than working with dozens of YAML files, you have sort of like, you still need those, but you abstract things out in the chart, and then you refer from the chart to whatever you need. But
yeah, exactly. Essentially, you just take all the YAML that you have, throw it in the templates folder for a particular application. So you can see here we broke down the web tier, the API tier, and then we broke it down into deployments and services. Yeah. Oftentimes, you'll see even more files in this, but this is just a simple 3-tier example. And then something I'll call out here. So he just showed the web tier deployment file. Mm-hmm. Now, if you look at the metadata.name, you'll see something funky. This doesn't look like YAML. And that's because it's actually using Go templating language in order to provide these parameters. So in Helm, there is an important object called release. What that does is it's natively created whenever you create any sort of Helm chart in your cluster, and it provides a unique name for that deployment. So oftentimes you'll see some sort of funky wild rabbit-ASP core web-dep. And so what that does is it provides you a unique name to allow you to deploy the same chart many times on your cluster. Additionally, in the containers section, you'll see the image also has a parameter for the build number. Now, this one is actually inherited from the values file, which can be updated at release time for the application. So if you want to just cat the values.yaml, you can see really simple file. All we have is build number, build number. What this means is that we're setting the default value for that build number parameter as just something arbitrary. And then when we're doing the build and release cycle, we override that value based off of whatever the particular build number is.
Yeah, absolutely. So we will revisit this particular aspect of the templates in a bit when we look at the build definition and why we need that. Let's do this. Let's take a look at the charts.yaml. Well, it's pretty simple. We have the version and we have a description, the name. This has to be unique, and this is the version of this particular chart. So you wanted to have some naming scheme here that is consistent with your versioning system.
Yeah, and the real purpose of the chart.yaml file is to provide all the metadata for your application or for your chart. So, for example, you can search Helm repositories just doing to look up different charts. And so having keywords and whatnot associated with your chart really helps in that process.
So right now, I think I have few already deployed. So if I do Helm LS, we have one deployed vs VSTS Helm release, and this is something we'll look into, like how we can automate this. I mean, as a developer, you can do it pretty easily using the commands. We're not going to go in detail from a specific like a dev environment setup in this, but that's probably something that we can discuss separately if you are a developer and you wanted to set it up. But the idea here is that once you have the packages available to you, and now you wanted to push those into a higher environment, maybe test or QA, then how that story is really going to work. That essentially bring us to really building the pipelines with Helm. Now, one thing important to understand, like without Helm, you can totally go in and you can do the release to the AKS cluster just using the regular kubectl commands. But then the issue really is that you're managing different files, and then every time when you release, then you have to make sure that you track all those specific tasks individually. So the first thing here is that you need to create a build, and you have a pipeline where you will be creating a container. Now this is not different than you may already be doing it for Docker based solutions, so that's not going to change. What's going to change is just the fact that you're using Helm. So when Daniel was showing you the build number cannot be static. Every time there's a build, you wanted to associate a version with it, and that version need to increment or at least change based on some criteria. So we'll see that. So this is important that build number get updated in some meaningful way. So you need to do that as part of the build, and then you need to make sure that the Helm package is released available as an artifact, because if it's not going to be available as an artifact, then you won't be able to use it during the release phase. So let's do this. Let's take a look at all of this. So this is the build definition, and let's take a quick look here. Let's walk through. So because we have an ASP.NET Core application and the Node application, we are basically starting with the .NET Core application. We're building it, so we want to make sure that it's going to compile fine. Now, the code itself is essentially the same that I showed earlier on, so it should be no surprise. This is the code again. This is from the Git. Now, technically speaking, you don't have to push it in VSTS. You can keep it on Git. And you can basically, every time when you do some check-in, you can have the Gator check-in in Git, and then you basically kickstart the build over here. So again, many permutations and combinations that can be done, but in this case, I just pushed it here. Now, once you have your project published, so now you have the actual assembly ready, you will go ahead and create a container. Now, this is important that we do it every time, because we want to make sure that we are releasing the latest code. Now, this particular task here, this if you're familiar with Docker, then this maybe you already know what this is. But essentially, what it allows you to do is it allows you to build, and then it will allow you to publish the particular image to the Docker. Now, Docker registry. Now, the Docker registry itself can be the public registry, like the Docker Hub, or it can be a private registry. If it's a private registry, and right now I'm using a private registry, which is basically provided by Azure. So in Azure, we have the ACR, Azure Container Registry. So you can see that that's why we have the value here. That's the name of the registry. Again, I mean, if you wanted to just try it out without like a public, you have a public repo, you can do that. You don't have to use this. And we're telling it that, hey, we wanted to push the image. So first you build the image and then you push it. So again, this is now we have to do the same for the Node.js. We build it, we publish it. But then finally, we're going to do something interesting with Helm. Now, the point here is that the build number in the, let's actually go back real quick. So if you open up if we go into the Helm charts over here and look at the value, so we have the build number here. This is more like a placeholder. So what we really want to do is that every time in the build run, we don't want to create an image with the version number saying build number, because it will be similar to saying latest or just you're hard coding it. So what we're trying to do here is that when we run this build, we will take the build ID, which is basically a numeric value associated with the build number. Whenever you run a build, VSTS will give you a new build ID, and we basically replace that in the values file. So essentially, what we're doing is that we find that build ID, we take the build ID and replace it with in the values.yaml. Now, again, this is not necessarily the best practice. This is one way of doing that. I mean, you can have anything from your own custom logic. You can do that. You can even just use, for example, a hash. You can do multiple things with it. But the important thing is that you have to make sure that it's unique enough, because later on, you need to make sure the Kubernetes can, depending on the policy that you set up, it may not even download the new image. So we are basically forcing it to do it, because we are always going to give it a new ID. Now, once you have this done, you will basically going to publish this as an artifact, because again, we will deploy based on the Helm chart. So we need the updated value. And I mean, I basically have I added a little bit of steps for the debugging here, but pretty much that's what your typical build definition look like for containerized application. And for Helm, you basically need to make sure that you have some way to update it. Now, once the build is done, you can basically run it. You can queue it. So I will go ahead and queue it, and it will take few minutes to run. But while it's running, let's take a look at the release here. The release is actually much more concrete and simple. You basically, I have this task. This is not even mandatory. I find it super helpful. I test my connection and list all the services. So I just know that my connection to my AKS cluster is working fine. If you wanted to create a new connection, you basically use the manage connection option here, and then you'll provide your config value. So if you do kube config, you basically wanted to get that value out and put it here. I won't show you here, but I think there's a good documentation that how you get that. So basically just connection testing here. Then I need to create a secret here, and the reason why I need to create a secret, because again, I'm using a private registry for the Docker images, and I think that should be the way that everyone should be doing, at least in an enterprise environment. So you should be using a private registry, and then in order to connect to it, you will need a password, user ID and password. So Kubernetes provide out of the box way to do it. It's pretty simple. This task actually just about creating the secret here. So I do that. I will list the secret and make sure that it's ready. Again, this is optional, good for debugging. And then finally, the task that is related to Helm is basically this one. Now this is in preview, so depending when you're watching this talk, it may change a little bit. But I think that the main thing to look into is the command here. So I'm using the upgrade command because my intention is that I will run the same release again and again whenever I'm doing an update. Now you need to make sure that your version is the one that you're running on the server. So there's a server side of the Helm, which is the tiller. So you want to make sure that the version is the same here. I'm using 2.9.1, but if yours is different, then you should be looking at that. Daniel, do you know the easiest way to get to the version number? I think it's
yeah. So I believe you can just type Helm version or -- version.
Yeah.
Or no, just Helm version.
Yeah, here we go. So it's 2.1, 2.9.1. And the server component for this one is the tiller.
Yep. And so you can see tiller is the same version as the client side Helm.
Yeah.
So tiller runs in the kube system namespace. So yep.
All right. So this is it. This is right here. So I think it's important if something is not working ever, especially in the context of Helm, make sure the tiller is up and running. So it's running fine. All right, so let's go back here. So
one more note there. If you're trying to get Helm up and running on your cluster for the first time, it's as easy as running just a simple command Helm space init init, and that will initiate the tiller pod in the kube system namespace.
Yeah. I think we should probably do a separate talk where we just get started, everyone. This is more like a part like, oh, we already have it up and running. But yeah, I think this is important that your server side should have this pod running and the version. You need to know that which version you're running. So it's right here, 2.9.1. Now, with the upgrade command, you need to pass the name of the release, and then in this particular case, because remember, the artifacts that Helm package take, it has to be somewhere. So if you go back to the actual task here, what we are telling it to do is publish the package. Like the values and then all the chars basically to the artifact as an artifact into the VSTS. So that's a really specific aspect of VSTS that we basically wanted to publish items as artifacts, so you can later pick them up during the release. So all we're doing really here is that we're saying that, well, okay, so where are the chars? This is the chars, and this is working directory is essentially the directory where these chars going to be. So that's what it is. And then we're also sort of like forcing it to go and download. At some point, you need to download the container images. So we are telling it that this is the name of that secret. So remember, we created the secret over here. Now, one thing keep in mind that because you're running it in an automated way, you can actually play around here with the control values. And do you want to continue on the error or not? But that's a little bit on the what actually you wanted to do if there is an error. I'm right now don't want to continue an error. So if there's a bug, then I just wanted to have my release halted. That's what I want to do. All right. So what we're going to do now is we just first check the build. Hopefully it's done. And yeah, so the build is completed now. So, and if you look at the logs here, so basically we got everything covered here. So we should be good to go and kick a starter release here. So we have the environment here, and you will know that which version because the build. So you see that this one is 30. So it automatically picked it up. So the artifact is 30. And we kick it started. Now this will take a few minutes depending on the agent.
So essentially, really what this does is it streamlines the deployment process by adding in Helm to it, as well as removing any sort of dependency on the particular CI/CD pipeline that you're using. It allows you always want to prefer with open source to be as to really lean in as much as possible and really utilize the native aspects of that. And that's really what Helm does. It allows you to remove any sort of dependencies on both deploying the application manually, so it shortens the time there. Rather than running 4 commands for this application specifically, you run a single command. As well as, looks like there was a error.
Yeah, so this is like a false positive because I already have the secret created.
Oh, okay, word.
Yeah.
But yeah, that's about it.
Basically, it ran properly here. So if you look at this, it went in, it took the charts, it deployed it. Basically, you can see that we have the Node API, and then we have the ASP.NET Core web app as a front end, and we also have the service endpoint, which essentially is the load balancer in this case because we're hosting it on Azure. So if I copy this and I go here and paste it, boom, this is our application deployed using Helm and running on AKS. And we can also like confirm it, like, so if I do get pods, so we'll see the pods here. Look at this one. So this one, 54 seconds. So it just got, and you can see that the old one that I replied like, wow, it's almost like 13 days, is terminating now. So just a couple of thoughts here. Like, this is a walkthrough, and I think each aspect can be its own talk. But this is just to show, like, holistically, like if you have experience with Kubernetes and you're looking into Helm and you wanted to integrate with your existing pipeline, then end-to-end things actually work pretty good. There are a couple of things that we can probably take a stab at later talks, like, for example, setting up Helm on a local machine, bit more around like upgrading your application. Like, how do you do that? Maybe some other details around there that you need to take care of. So with that, I think there are a couple of resources that we publish on this one. There's a multi-part blog series that Daniel and I are working on. Published the first 2 parts, so we're going to be covering a little bit on the VSTS and the release part that we showed already, and we will conclude the series with some lesson learned. Daniel, any concluding remarks you wanted to make?
Yeah, so I hope this was a really good introduction to what Helm is and how you can integrate it into your CI/CD pipeline, specifically using VSTS. If you're interested in more detailed explanation of everything we covered today, check out the blog series. We have the first 2 parts out, and the remainder of the blog series will be coming soon. Really appreciate you taking the time to learn a little bit more about Helm and VSTS.